Assalamualaikum and good day everyone. Now we want to solve example 2.5. Let's start. We're given 100 Newton force. This force is directed at an angle of 30 degrees with respect to AA axis. And AA axis seems to be our horizontal axis as well. To ease our reference, I will call this 100 Newton force as F. So F can be written as a summation of its component along A and B. Since we have three vectors here, we can solve this problem either using trigo approach or using rectangular component method. I'm going to start by using trigo approach. The first thing that we should notice here is that this 100 Newton force will come from a combination of two vectors that lies along A and BB axis. So the vectors are supposed to be along this orientation. Why they should be along this orientation? Because the sum of them should give you F. So we can say this is FA and this is FB, such that sum of them will give back F, basically this vector here. And we know based on the angle given, the angle here is 30 degrees, the angle here is 30 degrees. The total angle here will be 60 degrees, or we can say that this angle here is 30 degrees. The angle here is 60 degrees. And we can draw back the vector here in a much simpler form as something like this. We have our vector FB, an angle of 60 degrees, respect to horizontal axis. Next, we have our FA. Instead of drawing FA here, I'm going to draw FA here. This is my FA, which starts from the endpoint of FB. And we know that the resultant should be from the starting point of FB and ends at where FA ends. So this is our vector F. And again, we can fill in the angles. It's 30 degrees. It's 30 degrees. The angle here is 120 degrees. Once we have all the angles within this triangle, we can start to solve using trigo approach. In this case, we know that since F is equal to 100 Newton, we can use sine rule for the problem. Let's start with FA. I can take FA over sine of angle opposing FA, in this case 30 degrees, will be equals to F over sine of angle opposing F, in this case equals to 120 degrees. So FA is equals to F, which is equals to 100 sine 30 degrees over sine 120 degrees. So we can get FA equal to 57.74 Newton. Using the same sine rule, we can take FB over sine of angle opposing FB, in this case equals to 30 degrees, equals to F over sine of angle opposing F, in this case equals to 120 degrees. So we will get FB equals to sine 30 degrees times F, which is 100 over sine 120 degrees. If we refer back to this equal, so we will end up with the same magnitude, 57.74 Newton for FB. Now we'll solve the problem again, however, this time around using rectangular component method. So the idea is simply to resolve everything along X and Y axis. We'll resolve first along X axis. So in this case, we'll have component of F along X, Fx, will be equals to component of A along X plus component of B along X. In terms of magnitude, Fx will be equals to 100 minus cos 30 degrees equals to Fax equals to minus Fa minus Fb cos 60 degrees. We cannot solve this problem because we don't know Fa and Fb. So now we will look into the equation along y-axis. Along y-axis, we will have Fy equals to Fa along y plus Fb along y. Fy will be equals to minus 100 sine 30 degrees, while Fay will be equals to 0, and Fby will be equals to minus Fb sine 60 degrees. We have one equation, one unknown, so straight away we can find Fb equals to 100 sine 30 degrees over sine 60 degrees, which is equals to 57.74 Newton. Once we have our FB, we can substitute FB into above equation. We'll get FA equals to 100 cos 30 degrees minus FB cos 60 degrees, which is equals to 57.74 Newton. We are getting the same answer when we use the rectangular component method as well as when we use single approach. That means our result should be correct.